Hello, everyone. It's June 13th. Alright, so didn't really solve this problem yesterday. I gave it some thought. I think I have a new idea, but we'll have to take a look at what problem we have today. Maybe we'll do it, maybe we're not. Oh, I think we are, because it's the easy one. I definitely can do it. Alright, maximum difference by remapping a digit. You're given integer num. You know that Bob will sneakily remap one of the 10 possible digits to another digit. Return the difference between the maximum and the minimum values. The maximum and the minimum values that Bob can make by remapping exactly one digit. Return the difference between the maximum and the minimum values Bob can make. So Bob can change one, right? When Bob remaps a digit to another digit, Bob replaces all occurrences of it. Bob can remap a digit to itself, in which case num does not change. Bob can remap different digits for obtaining minimum and maximum values respectively. The resulting number after remapping can contain leading zeros. So, apparently, 11891, right? If I want to get the maximum, I remap 1 to 9, so I get 99899. And if I want to get minimum, I get this one to 0, so we got 00890, so the difference is 99009, right? So if it's 90, I remap 9 to 9, I remap 9 to 0, so the answer is 99. Oh, we don't. Okay, yeah. If it's already 9, why would you remap this to 9 and remap this to 9? Okay, so, okay. What will be easier when you do this remapping thing? I think to turn it into a string will be easier. Not really a string. I would say to turn it into get each digit, put it into an array, and then we just go through each one. Find the first one that's not 9. We'll map it to 9, and then yeah, I think that's how I'm gonna do it. Okay, so we say vector int digits. Okay, then we're just gonna go I guess it's fine. I guess it's fine. You can say while num is larger than 0, digits dot push back num not 10. Okay, num divided with a 10. So this is left to right. I mean right to left. I have to read from right to left, right? And then we can say the max possible. Right, the max possible will be to just go right to left, find the first one that's not 9. We say, oh, I'll turn this into 9. And also, we'll turn the first one into 0. And once we've done that, do we create another array or... I feel there are easier way. For example, maybe we can turn num into string. Okay, how do I do that? Into string. Num to string. I forgot. To string. C to string num. Okay. Yeah, I feel like this is an easier way. Alright, I get that. And then we say max swap. Alright, who do we swap to 9? Alright, map swap. And then min swap. Yeah, I'll do max swap. I don't know what it is, right? So we say for int, and say for char d of num string. Okay. If d is not equal to 9, then max swap shall equal to d minus 0, and then we'll break. And then min swap, and then we can do int max, and then we go from right to left. We say for int. I can actually write a function for this. Right, int get swapped number. So we'll have an str, have a string, an str, and then swap digit. Swap digit, swap from, and swap to. Okay. Alright, so what do we do here is we're gonna say int rest equal to 0, and then we're gonna go from front to back. Because every time I so for int I equal to 0, I'll char c of num str. If c minus 0 is equal to swap from int d equal to check c minus 0, right, is equal to swap from. Okay, if it is, then we use swap to. Otherwise, we use c minus this. Okay, and then we say rest equal to rest times 10 plus d. And then we do this until we return rest. Right, so that's that. And here we can do min swap shall equal to 0 minus 0. Now we return get swapped number num str. So this is swap from max swap to 9 minus get swap. This is still num str, and this is gonna be min swap, and then this is gonna be 0. Okay, let's check. Has to be number. Too big? Too big. Oh, edge case. one looks good. Yeah, I think this one looks good. What? Ha! Wow. Find the first knot of 9. Replace it. Ah, S2I. Yeah, I didn't know there is a. You can do swap. Huh. Wow. You gotta be kidding me. And then it has to be a find the first off, right? Do we have find first off? Yep, we have find first off, we have find first not off. And then of course we also have the replace. To make a copy of the string. Good solution. And also S2I. Actually, I don't even need. Oh, I need because I'm basically doing everything by hand. All right. Anyway, so yeah, that's that. Let's take a look. All right, back at yesterday's problem. So the epiphany is, like we want to find a pairs with minimum, right? With minimum difference. Now, if you have repeated numbers, then you can get zeros out of them. So you should get all of them. So basically, my proposal is we'll read through this, we'll produce a counter for every single element. And after we produce the counter, if the counter has even numbers, then it's gone, right? It's just going to be 0. We'll pair all of them up. If it's odd numbers, then we can pair even of them, so we get 1 left. So eventually, after we do this pair, we'll have a map with just single values, right? With just single values. And with the single values, the next thing we do is just, we need to see how many more pairs do we want, right? And now we just have a single string of numbers. Like in this case, we have 10 have 1, right? 1 has 2, so 1 is 2, 2 is 1. Actually, let me redo this. Let's do it right. I have 10 is 1, 1 we have 2, 2 I have 1, 3 have 1, and then 7 has 1. So this basically gone. And then after this we removed so P have 2 and 1. We have 1 more pair, right? We have 1 more pair to go. And then we just have this 2, 3, 7, 10. Give me a pair that produces the smallest value. And then it's going to be this pair. So what you can do is you can do this, right? You can do this. All right, this give me 1, this give me 4, and this give me 3. And then you're going to have a bunch of values and just need to pick. Now, what I'm thinking is in a scenario where you have, let's say, 3 of them, right? You have A0, A1, and A2, and these produce the same, right? Same K. We don't know what it is, but it's the smallest. So when this happens, I think you can do the same thing. Yes, it's essentially the same thing. So you produce like a counter again, right? Like this just means we have 3 elements, right? We have 3 elements that can produce. Actually, it's slightly different. I think it's slightly different. Like this can produce, let's say, a Q, and a Q is bigger than K. Yeah, and then you definitely won't choose this. You'll choose this. So essentially, you can go through this. You find a difference, right? And you find a difference. So you find a difference. Yeah, then what? Like, what do you put in here? So you say, okay, I have a K and I have A0, right? And then next one we have a K, we have A1. Next one we have, we have all of these. And then just start from the beginning. You'll take this, right? And if it's gonna be used, so you just remove this, you skip, right? You don't take. I think we proved this. If you have these kind of chain, you always want to take the first one, because if you don't take the first one, you take the second one. If it's odd number, then there's no difference. But if it's even number, like if we have this another K, you don't take this, but you take this, then you actually have worse. So yes, that's essentially what we're gonna do. In fact, I am going to do this, yeah, because it's kind of a new idea. Ugh. All right. So here is my new idea. We produce a counter, right, of nons for each element that have even count. We can produce count divided by 2 number of pairs with difference, with minimum difference, right? Minimum min difference for each element that has odd count. We also can produce count divided by 2 pairs, but we will have one left, right? But we will have one left. Thus, after this round of getting zeros, right? Getting zeros in difference, we will be left with just single values, right? Just single values. Then we can go through them and just pick the pair with the smallest difference. So I think I'll call it O(n log n) because I'm going to use a ordered map, which I think is just called a map, right? So and then we say for int n okay, so that's that. Oh, it's not map, it's counter. And then we say I'm not sure. I forgot how to iterate through a map. remember this. Yeah, of this. Exactly. Why do you keep calling a map? It's a counter, right? If no, we can do p dot first. So int 0 pairs, right? So equal to p dot second divided by 2, and then p. Oh, we have p already. Call it pa. And p will minus equal to 0 pairs. If p is smaller or equal to 0, then we return 0. Okay. Otherwise, we say counter pa dot first minus equal to 0 pairs. Okay. And now we're at the end. Then we need to know we need to sort the diffs, right? Then we have to have a diffs vector of pair. And then again for const auto pair of counter, if pa dot second is equal to 0, we'll continue. Right. Otherwise, I need a previous number. So int previous. Okay, now we say if previous is equal to -1, then you say pre equal to pa dot first, right? Else pre is not equal to, so you have a pre, you have the current, then you can compute the difference, right? So we can say diffs dot push back is going to be pa dot first minus pre, and we'll get pre. We put pre in there, right? And we say pre equal to pa dot first. So the only difference is, we always get pre equal to pa dot first. After we've done it, pre is this, and then this until the last one, right? The last one. Okay, so we can change this. We can just say if it's not equal to -1, which I don't think it's going to be -1. I think everything is positive. Yeah. So if it's not -1, we don't need to do this. We just do this, and then we don't do this, and then we do it here. Make sure we do this one every single time, right? And then when we're done, we can do technically we can do another map, right? Because we can sort based on the then this can't be, then this is an unordered map. No, it has to be an ordered map. This has to be an ordered map, and then we have a difference, and then we'll just sort. Right, we sort diffs dot begin, diffs dot end. Right, we sort it, and And then we just go from front to end. Okay, for I0, alright, I smaller than diff.size, I plus plus. And then what we check is, I take this as the next one, right? So I check the previous plus the difference if it's equal to the next one, right? So we can say if I is larger than 0 and diffs I minus 1, right? Diffs I minus 1 dot first plus diffs I minus 1 dot second is equal to diffs I dot first, no, dot second, right? That means we use this already, then we cannot reuse it, then we just continue, right? So yeah, we have used diffs I dot second already. Otherwise, then we just say, p minus minus. And p is larger than 0, right? And then we have the interest. They say res equal to std max res. Actually, I don't even need to do the max because all I need to do is just diffs I dot first, and at the end we return res. All right, let's try this one. Now, sure. Okay, looks solid. Let's give it a shot. Wrong answer. Dude, so let's see. We have 8, 9, 1, 5, 4, 3, 6, 4, 3, and a 7. Right? 8, 9, 1, 5, 4, 3, 6, 4, 3, and 7. So these two get rid of 1 is 1, so we have p equal to 2. Right? So now we have 1, 5, 6, 7, 8, and 9. And this will give me 4, 1. This is 1, 5. This is 1, 6. This is 1, 7. And this is 1, 8. Sort them. We'll actually move this to here. Right, so I'll get this. Oh, I know why. I forgot. I need a pre as well. Shit. Okay. Oof. Dude. Pre. If this is not this one, it's the previous used one, right? Previous used one. Oof, previously used one, previous index. Previous index. Oh yeah, previous index. Pre-used index. Pre-used index. just say if I probably don't even need to use this because it's adjacent, right? So as long as the previous use index, so as if pre-used index is equal to I minus 1, then we skip. So we get this, let's say get it bigger, so it won't hit this, right? Because I'm gonna use this if the previous use is the previous one, right? Then it must involve me, but otherwise it won't. So otherwise we'll do this, and then we say a pre-use index will equal to I used I, right? So the next one, yeah, I think that probably will work. Okay, let's use this test case, try it. Yep, I think this one shall work. Ugh. Nope. Damn. Alright, we have 3, 5, 0, 1, 6. 3 zeros. Alright, 1, 2, 3 zeros. So p equals to 3. So this one will get rid of. So we end up p equal to 2. So I need 2. So I have 0, 1, 3, 5, 6. This is 1 and this is 1. How is this not right? Because I'll get 1, 0, right? This is a pair. And then 1, 5, right? 1, 5 is a pair. And then we have 1, 2, 1. And we have 2, 3. It's like, wait, what? How is this? I'll get this? Oh, you need to find this. Oh my god. Oh, yeah. Blah, 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 blah. I got it. Yeah, this is not right. So it's a pre-used index. Pre-used index, we go in there and then we try to see if the current one is being used. So if pre-used index is alright, so yeah, so it is this. If pre-use index is logic to 0 and call it pi. If pi is logical to 0 and diffs pi dot first plus diffs pi dot second is equal to diffs I dot second, then we continue, right? Otherwise we just do this and then we have pi. Alright, come on, this is easy logic. Can't believe stumbled. This is actually very similar to how we first wrote it. Alright, let's see. Does this one work? Oh, wow. I don't know. So we have 0, 3. Right? The diff output 1. Yeah, 1 should be skipped, right? Because p is 0, so I skip 1. Oh, 1 is not 0. 0. It's a 0 because it's counter. Right, so it's a 0, 1, and 3. that's actually not right. I mean, there are multiple issues with this one. Because in my mind, I'll take off this, and then this actually, it shall give you 3. Damn it. It will give you 3, but the answer is 2. You're not supposed to do it that way. You're supposed to do this and this instead of, oh, wow. Ugh. So yeah, it doesn't work. I actually don't know. Oh my god, this doesn't work. Oh, this does not work. It's wrong. Yeah, it's wrong for different reasons. All right, I have to stop here. So, wow, there are some hints. We haven't checked the hints. I have to take a look. Okay, we store the array. Ugh. Okay. It tells me to do binary search. All right, I have to think about how to do binary search on this. All right. Anyway, that will be it for today.